Hi and welcome. We're going on and now we're going to be talking about these geometric optics. And of course, we're trying to put everything together in the time that we have. Now, geometric optics, here we learn about two types of lenses. And what are they? We have the converging type of lenses, and these are lenses that would bring light rays together at a point. They are thinner at the edges and thicker in the middle. Okay, and we're gonna see that type of a lens not so long. And we also have diverging lenses. These ones will spread light rays. Okay, they will spread light rays out. They are thinner in the middle and thicker at the edges. So you can see that actually these ones, the diverging lenses, are actually the opposite of what converging lenses are. Okay? Continuing with this, like we said, we're talking about two types of lenses. Now, when we talk converging lenses, we have what we call a convex lens. Okay? And under diverging lenses, we have what we call a concave lens. Okay? Now, how do they work? Lenses would always have a central point called the optical center. So every lens has a central point called an optical center. Okay? Light passing through this optical center experiences very little refraction or no refraction at all. So a ray of light passing through the optical center is usually drawn straight through that center. It doesn't sort of show any change in direction, because refraction is actually the change in direction of a light ray as it passes from one medium to another of different optical densities. Okay? Now, moving on. Refraction, the bending of light as it passes from one medium to another of different optical densities. So here when we say bending, you can actually say refraction is the change in direction. The change in direction of light as it passes from one medium to another of different optical density. Okay, the convex lens, coming deeper into it, we said that with the convex lens, this is a lens that converges light rays into a point. So if you've got, we know that light travels in a straight line. So light travels in a straight line. Okay, and because it travels in a straight line, it means that light rays are actually parallel to each other. So those parallel light rays are converged at a point when we're talking convex lenses. Let's have a look. The principal axis is the line that passes through the focal point and the optical center of a lens. Now this holds for all types of lenses, including the concave lens. Okay? The principal axis is the line that passes through the focal point and the optical center of the lens. And what is the focal point? Focal point for a concave lens is the point where all the light rays meet. And I mean, as all those light rays are converged to a point, that point where they meet is the focal point. Okay? And the focal length, so these are the terminologies that you should know about optics. The focal length is the distance between the optical center and the focal point. Okay? Going on, talking about concave lens. Here, with a concave lens, we know that it is going to spread out parallel light rays. So these parallel light rays are actually scattered and brought, made to go further away from each other. Okay? The light rays seem to be coming from a single point, which is the focal point for a concave lens. Okay? So instead of the focal point for a concave lens to be like that of the convex lens, where all the points come to, or all the light rays come together. This one, if you look at how they have been diverted, okay, you would see that if you prolong them, a point where they seem to come from becomes the focal point for a concave lens. Now here it's a convex lens, showing how the image is formed. Look, straight here at the center we've got the optical center, okay? There is the light ray there. Up there it is converged to a point. This one here has passed through the optical center and no refraction occurs, so it moves straight, it comes there. Another one down here changes direction, and where they all come together, it's where the image is going to be formed. Okay, so that's for the convex lens. For the concave lens, okay, we've got virtual image formation by negative lens. Here you've got this situation where the image is between the object and the lens, okay? And in the same way, this becomes your principal axis. That becomes the one ray that has been diverted there. And then if you prolong it this way, it comes to the focal point where you have your object formed. All right, see you in the next section.